In this video, we're going to talk about the chain rule for partial derivatives and using it to get what's known as the total derivative of a function. Now, as this video goes along, I'm going to show you a way to pretty much guarantee you get the answer right every single time. So let's get right into it. So let's say you're given a function that takes on the form z equals f at xy, then the total derivative of that function dz by dt is equal to the partial derivative of z with respect to x times dx by dt plus the partial derivative of z with respect to y times the derivative of y with respect to t, where x and y are functions of t. So let's take a look at this with an example. So let's say you have a function z equals f at xy, which equals x squared times y, and you're asked to find the derivative of z with respect to t if x is equal to 4t and y is equal to t to the power of 5. So how would we do this? Well, we do it simply by using our chain rule here. So the first thing we're going to do is we're going to try and find del z by del x, or the partial derivative of z with respect to x, del z by del x. Now, if we take a look at this function here, del z by del x, we'll take 2x, we take the exponent of 2, multiply it by x, and of course the y is a constant, and so there we have it. Now the next thing we're going to find is dx by dt. Now I'm also going to say at this point too, if you're not comfortable with partial derivatives, I'm going to put a link to this video to the first video I made about partial derivatives that shows you how to actually compute the partial derivative of a function. Otherwise this may not make sense. But anyway, moving on, we're going to get the next item here, which is dx by dt. So we come over here, here's the function x, and we're going to differentiate with respect to t. As we know, it'll just be 4 by our power rule. So dx by dt is just equal to 4. Now we're going to go and get the partial derivative of z with respect to y. So del z by del y. So in this case here, x is treated as a constant, and so y reduces to 1 here. So we go del z by del y. Y reduces to 1, and x is the constant, so we get x squared. And then last but not least, we're going to find dy by dt, dy by dt, and y at t over here. With our power rule, we get 5t, and the exponent here reduces to 4. So now we have what we need to get the total derivative dz by dt. So let's go ahead and do that. So dz by dt is equal to, we're going to multiply all these out. So we're going to get 2xy times 4 plus x squared times 5t to the power of 4. Okay, now as you can see here, all this is in terms of, it's not all in terms of t here. So what we can do to put it in terms of t is substituting. So what we're going to do here is we're going to go 2 times x, and in this case x is 4t, so 2 times 4t, times y, which is t to the power of 5, t to the power of 5, times 4. And then we're going to take x squared, so t to the power of 5 squared, t to the power of 5 squared, or excuse me, no, that's y, my bad. Let's correct this here. 4t squared. and then times 5t to the power of 4. Okay, so now what we can do is we can go ahead and simplify that, and in doing so you get, so you multiply the constants here. Okay, so 4 times 4 times 2, we get 32, and then multiply the t's, the exponents, or sorry, add the exponents of the t's, and we get 6. And then over here we have this expands out to 16t squared times 5t to the power of 4. And then we go ahead and simplify this even further. So we have 32t to the power of 6 plus, and so we're going to multiply these coefficients. So 16 times 5 is 80. And then we're going to add the exponents, and then we get 6. Okay, so we're almost there. So as you can see here, these two are both exponents are 6. So we can add the coefficients, and we get 112t to the power of 6. Okay, and that would be our answer. So now the question is, remember earlier I said there's a way to guarantee that you'll get the answer right pretty much every single time. So how do we do that? Well, what I showed you here is the long method. There's also a shorter method that you can use to verify this answer. And so in doing so, you should get the exact same answer using this shorter method. So what we're going to do is we're going to directly substitute 4t into x squared, and then, into x, and then square that, and then t to the power of 5 into y, and then we're going to take the derivative with respect to t. So we have z at xy, or sorry, z is equal to f at xy, xy, which is equal to x squared y, and then substituting the x in, so substituting 4t in, we get 4t, and then x is squared, and we're going to substitute our y in times t to the power of 5. And then from this point on, what we are going to do is we're going to multiply this out, so we get 16 t squared, and then we have just t to the power of 5. And so what we can do here is we can add the exponents. So we have 16t to the power of 7. So now if we want to get the derivative with respect to t, as you can see here, we can just differentiate z with respect to t directly. So what I'm going to do is we're going to go ahead and do that now. So let's take this, grab a different color here. Okay, so we have dz by dt is equal to d by dt of 16t to the power of 7. Now 16 times 7 is 112, and then we reduce the exponent to 6. And as you can see, these two answers are the same. Okay, so we got these two answers are the same. So that is how you calculate the total derivative of a function using the chain rule for partial derivatives, and how to verify that you have the correct answer by a way of direct substitution.